Hello everyone, let's start a new lesson today from class 10 science 1. So this is second lesson, periodic classification of element. Before starting a lesson, let's discuss few questions. First one is, what are the types of matter? So student, types of matter, what are these? Solid, liquid and gases. Okay. What are the types of elements? So first of all, we will discuss elements in this lesson, and then I will say types of elements. All right. Now, what are the smallest particle of matter called? Student, smallest particle of matter is an atom. All right. So, atom is the smallest particle of matter. Okay. Fourth one, what is the difference between the molecules of elements and compounds? So we will discuss this later in this lesson. Now let's start a lesson. Classification of element. First of all, what is element? So element is a basic unit of matter. They are pure substance made up of one kind of atom and cannot be broken down into simpler substances. So these are the elements, and we have different types of elements, like we have metals. All right. Types of elements are metals, non-metals and metalloids. Okay, so these are the types of elements. So student, till now 118 elements are discovered till now, and elements are made up of identical atom. For example, chlorine. Okay, so in chlorine all the atoms are in chlorine element all the atoms are similar type. All right, so this is a structure of an atom. So student, this is in the center of an atom. Okay, center of the atom we have nucleus, and nucleus is a positively charged. All right, charge of a nucleus is positive and it is due to the proton. So in nucleus we have two particles, protons and neutrons. Okay, proton is positively charged, neutron is neutral, and around the nucleus of an atom different shells are there. Okay, so this is first shell, second shells, different shells are there, and in particular shells electron are revolving around the nucleus in a particular shell. So this is a basic structure of an atom. All right, now here two terms are there. First is, these are the properties of a atom. Okay, first is atomic mass. So what is atomic mass? In nucleus we have proton and neutron. Okay, so atomic mass is the sum of proton and neutron. And second property is atomic number. So what is atomic number? Atomic number is the number of proton or electron. Okay, number of proton or electron in an atom. So this is an atomic number. So this atomic number is represented by letter Z, and atomic mass is represented by letter A. All right, so the basis of classification. So student, there are three different scientists gave the different methods of classification. So let's study one by one. So first is Dobereiner triads. Second theory, Newlands law of octaves. And third one, Mendeleev's periodic table. Okay, now let's just discuss one by one. First is Dobereiner triads. Okay, so this scientist Dobereiner suggested that properties of elements. Okay, so properties of elements are related to their atomic masses. Now what is atomic masses? Just now we have discussed this. This is number of proton plus neutron. Okay, sum of proton and neutron is the atomic masses, and he made group of 3 elements. Okay, so he made group of 3 elements which have been discovered till then, and 3 elements each having similar chemical properties, and called them triads. Okay, called them triads. So this was about the first theory, Dobereiner triads. So these are the triads. What are these? He made group of 3 elements. Okay, 3 elements each and having similar chemical properties, and called them triads. So here one example is done for you. For suppose he took 3 elements which have similar chemical property. Okay, first one is lithium, sodium and potassium. So these are the 3 elements, and atomic mass is also given by the of this element. Lithium 7, sodium 23 and potassium is 39. Okay. Now what was the theory is atomic mass of the middle element. Okay, atomic mass of the middle element. For suppose here middle element is sodium. So atomic mass of sodium was approximately equal to the mean of atomic masses of the other two elements. It means atomic mass of sodium is approximately equal to mean of atomic masses of the other two elements. So let's solve this. Okay. Now here sodium atomic mass is 23. Now we have to calculate mean atomic mass of lithium and potassium. Okay, mean atomic mass is lithium plus potassium divided by 2. Now here lithium atomic mass is 7 plus sodium is 39. Alright, divided by 2. Now 7 plus 39 is 46 divided by 2, and here we will get 23. Okay, so mean atomic mass of sodium and lithium is 23, which is exactly equal to the sodium. Okay, so this is a triad theory in which the sodium atomic mass is approximately equal to mean atomic masses of the other two elements. And student, this is not applicable for all the elements. Okay. Alright, now second theory was Newlands law of octave. Now what is it? Newland arranged elements in increasing order of the atomic masses. Okay, so he also arranged the discovered element. So till then 56 elements were discovered at the time of Newland, and he arranged all these elements in increasing order of their atomic masses. That means proton plus neutron. Okay, and he told that every 8 element, all right, every 8 element had property similar to those of the first. So student, here one table is given to us. Musical note are given. Musical note, Indian musical note, we have sa, re, ga, ma, pa, dha, ni. Okay, and these are the western tones, which are do, re, mi, fa, sa, la, ti. Okay, so these are the western as well as western and Indian musical tone. So what he told that every 8 elements. So in music, okay student, in music we have first, we have the same tone of same note for first and last tone. Okay, so like sa and ni, they have the same sound, and do and ti, so the sounds of do and ti note are also same. So he just compared this tone with the element also. That means every 8 element had property similar to those of the first. Here tables are given. Table is given in which first element is hydrogen. Okay, first element is hydrogen, and from the hydrogen 8 element is what? Fluorine. Okay, like here 1 2 3 4 5 6, sorry, from here 1 2 3 4 5 6 7 8. So he told that property of first and 8 element are similar. Okay, 8 element had property similar to those of first. That means here hydrogen and fluorine, they have the similar property. Lithium and sodium have the similar property because first, and this is 8 element. Beryllium, magnesium had similar property. Boron, aluminium, carbon, silicon, nitrogen, phosphorus and oxygen and sulfur. So like this, first and 8 element have the same property. Okay, so Newland compared this, okay, compared this with octaves in music, just now I have told you, and he called similarity observed in the 8 and first element. Okay, 8 similarity observed in 8 and first element as law of octave. So this is a law of octaves. Okay, and you have seen the you are able to see the table which have been made by the Newlands. Okay, so now just look at the limitations of this law of octave. Okay, so first limitation is only this law is only applicable up to calcium. This law is applicable only up to the calcium. That means till here only this law is applicable, and after this, like chromium, titanium, manganese, ferrous, cobalt and nickel, this law is not applicable to these elements. It is only applicable to the calcium. So this is one of the limitation of this law. Now second, he placed 2 elements each in some boxes. Okay, so he placed 2 elements in some boxes to accommodate all the known element in the table. Like here cobalt and nickel, he placed 2 elements in one column. Cerium and lanthanum. Okay, so here 2 elements are placed in one table just to accommodate the boxes which were known at that time. Now third is he placed cobalt and nickel under the node DO along with halogens. So here fluorine, chlorine and bromine, these are the halogens. These are having different property than the cobalt and nickel. So he placed cobalt and nickel which are having different property with the halogen. Okay, and fourth one is ferrous, that means iron have similarity with cobalt and nickel. So he placed iron placed away from them along with the non-metals oxygen and sulfur. So iron is a metal and it having the similar property of cobalt and nickel. Okay, so these three are metal, but these are placed away from each other. Like here he placed iron with the non-metals, oxygen, sulfur with the he placed iron with the non-metals. So these are the non-metals, and ferrous, which is iron which having similar property of cobalt and nickel. So these are far away from each other. And fifth one is this periodic table did not have provision to newly discovered element. That means there are not empty boxes, all the boxes are accommodated. Okay, and here there are not empty spaces for the newly discovered element. So these are the limitations of a second law, Newlands law of octaves. Okay, now third periodic table was discovered by the Mendeleev. So Mendeleev periodic table. Now let's understand this, student. Mendeleev considered the atomic mass. Again, this scientist considered the fundamental property of an element, which is the atomic mass of the element. Is the standard property. Okay, and at that time 63 elements were known. So he arranged them. Okay, so he arranged the 63 element in increasing order of their atomic masses. Okay, so for suppose here the discovered elements were lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and sodium. Okay, so atomic masses of the elements are, I have written below. These are the atomic masses. Okay, so student, what he told that the lithium, lithium and sodium, and here in between different elements are there. So if we consider two elements like lithium and sodium, okay, so the molecular formula for oxides and hydrides. Oxides means this metal, this elements react with oxygen called as oxides. Okay, and this elements react with hydrogen called as hydrides. So the molecular formula, these are the compounds which are forming their oxides and hydrides. These are called as a chemical property. Okay, so these are the chemical property or chemical functions of the elements. And so you can look at here, Li2O, Na2O. That means two atoms of lithium react with oxygen, and Na2O, again here two atoms of oxygen sodium react with oxygen. Okay, so here formula can be, you can write here, formula can be this R2O, and here also R2O. R is an element. Okay, now with hydride also we can look at here LiH, NaH. That means here also the hydride formula, chemical formula is same. That means the ability to form a compound is the same, oxides also and hydrides also. And the physical property like melting point, densities and boiling point, these are also same. So this property, chemical and physical property are repeating after an interval. Okay, after an interval. That means lithium is there, sodium is there. So lithium and sodium, they are having the almost similar property, and this property is repeating after an interval of time. Okay, so here as lithium and sodium have similar properties placed in one column. Okay, so these two elements having the similar property, so they can be written in one column. So these are the column. Okay, so lithium, sodium written in one column. Okay, beryllium, magnesium written in same column. Boron, aluminium, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, these are the halogens, these are the non-metals. So the elements which are having the similar properties are written in one column, and these properties are repeating after interval of time. Uniformly it is repeating. Okay, so elements with similar physical and chemical property repeat after a definite interval. That means the lithium, in between all these, after lithium these elements are there. Okay, and after fluorine we have sodium, and sodium have the similar property with the lithium. Okay, that means it is repeating after an interval. So Mendeleev discovered his law, and it is called as a Mendeleev periodic law. What is the statement? Property of elements are periodic function of their atomic masses. Okay, properties of element. Properties are what? Physical and chemical property. So these physical and chemical property are repeating after an interval, definite interval of a time. Okay, with their atomic masses. Now let's have a look on Mendeleev periodic table. Right, now let's have a look on Mendeleev periodic table. So student, this is the Mendeleev periodic table made by Mendeleev. Okay, so here you can see the groups. Okay, these are the vertical groups are there. So vertical 8 column are there. So these are the group, and horizontal periods are there. Okay, like first, second, third, fourth, fifth. Now here you can see hydrogen, lithium. In first group there is hydrogen, lithium, sodium, potassium and copper. So these are having the similar property. Okay, similar property. And beryllium, magnesium, calcium, zinc, they are having similar property. Okay, so this here you can look at here oxides. Oxides means the compound will form, react with oxygen, and they form oxide. Like here first group we have oxide formula is R2O. R2O means like here hydrogen react with what oxygen, and it will form H2O, Li2O, Na2O. Okay, so this is a chemical property. And hydrides means H2. Okay, and here LiH. So this is the ability to form oxides and hydride. RO, RH2. So here different formula of oxides and hydrides are given to us, and here you can look at it. These are the halogens, non-metals are there, and metals are there, alkali metals are there, different metals are there. Now here you can look at here in 8 group we are having 3 elements in one column, one period. Okay, like ferrous, nickel and cobalt. And here if you will observe here, there are vacant spaces. Okay, their atomic masses were discovered. Okay, atomic masses of these elements were discovered, but name was not discovered. Okay, now let's so this is the Mendeleev periodic table. Now let's have a look on merits of Mendeleev periodic table. Okay, so first merit is atomic masses of some elements were revised. Okay, like previously discovered atomic mass of beryllium was 14.09. So Mendeleev corrected this atomic mass of beryllium as 9.4. Okay, and beryllium was placed before the boron. Okay, now second one, he kept vacant places in the table for undiscovered element. Okay, just now I have told you that he placed vacant places for the undiscovered element, but atomic mass he discovered. Okay, like first is, all right, now first element is icaboron. Okay, this first one is icaboron, second one is ica aluminium, and third is ica silicon. First icaboron, ica aluminium and ica silicon. So here atomic mass is given. Okay, so atomic mass of icaboron is 44, 68 and here 72 respectively. All right, now after then he discovered, so now after the Mendeleev, this name of these elements which are undiscovered was discovered as this. Icaboron is scandium. All right, this was scandium, which is Sc. Then ica aluminium as gallium, which is Ga, and third is germanium, ica silicon as germanium, right, germanium, which is Ge. Okay, and the properties of these elements, okay, the properties of these elements were matched well with those of the predicted by the Mendeleev. So here I am writing the name. First is Sc, second is gallium, and third is germanium. All right, now third property is no place is reserved for the noble gases. Okay, now here student, you cannot see the here place for the noble gases. Okay, So there is no place for reserve for noble gases, and he created group 0 without disturbing original periodic table. Now after the discovery of noble gases, he again created, after this 8 column, okay, after this 8 group, he created a 0 group, without disturbing this element. Okay, now here we can here there will be helium, noble gases like helium, neon, argon, krypton. All right, so these are the merits of Mendeleev periodic table. All right, now there are some demerits also with the Mendeleev periodic table. Now first is atomic mass of cobalt and nickel are nearly same. You can look at here. Atomic mass of cobalt is 58.9 and atomic mass is nickel is 58.7. So almost it is same. So there is big confusion. There was a big ambiguity, that means big confusion regarding their sequence in the table. Then where that means to place this element there was very big confusion because their atomic mass is nearly same, almost same. Okay, now this is first demerit. Second is isotopes. First of all, what is isotope, student? The compounds have the elements having same chemical property. Okay, the chemical property will be same, but their different atomic mass will be but their atomic masses will be different because atomic mass is related to the protons and neutrons. Okay, so same chemical property but different atomic masses is the isotope. So after the discovery of isotope, long after the Mendeleev periodic table, as isotope have the same chemical property, all right, same chemical property but different atomic masses, a challenge was posed in placing them in Mendeleev's periodic table. That means where to put the how to put the isotopes in the periodic table. So this is also a big confusion. So let's have a look at an example. Here I have given you example isotopes of carbon. Okay, so carbon 13 and carbon 14, their atomic number is same. That means they have the same chemical property, atomic number is same. That means carbon C6 13 and C6 14 have the same chemical property but their atomic mass is different. The atomic mass of carbon is 6, okay, and atomic mass is 6 plus 6, that means it should have 12. But it has two isotope which is 13. In 13 we have 6 proton, 7 neutron. In carbon 14 we have 6 proton and 8 neutron. So there is also big confusion to place the isotope in a Mendeleev periodic table. Now third is, when elements are arranged in an increasing order of atomic masses, the rise in atomic mass does not appear to be uniform. That means the increasing order of the atomic masses is not uniform. It is not gradual. It is randomly increasing. Now you can see here I have put the series over here. Sodium, magnesium 23 and 24. It is okay. Okay. Now if we will move from magnesium to aluminium. So atomic mass of magnesium is 24 and atomic mass of aluminium is 27.3. That means 27. So here one difference in atomic mass is 1, but here difference in atomic mass is 2. Okay, so it should be 23, 24, 25, but here it is not uniform. Like here, aluminium to silicon it is 1, silicon to phosphorus 28 and 31, then phosphorus to sulfur 31 to 32. Again it is one difference is there, but this sodium sulfur and chlorine it is 35.5. Okay, so there is not uniform increase and uniform rise in the atomic mass. It is like just randomly it is increasing. Okay, so it was not possible therefore to predict how many elements could be discovered between two heavy elements. Okay, for the two heavy elements there was a big confusion was there, like in cadmium, indium and tin. Okay, so cadmium atomic mass is 111, indium atomic mass is 113. All right, now in between indium and tin, 5 differences there because it is 113, 118. So it was not possible to predict how many elements are discovered between indium and tin. All right, so this is third demerit. Now fourth one is about hydrogen. Now position of hydrogen. Hydrogen shows similarity. Okay, hydrogen shows similarity with halogens as well as alkali metal. Okay, so again there is a big confusion. that in periodic table where to place a hydrogen, either with halogen or alkali metals, group 1 or group 7. Halogens are placed in group 7, alkali are placed in group 1. Okay, so here elements and their molecular formula is given, like we will see, like hydrogen. Okay, hydrogen, H2, and chlorine, again we have the same formula, Cl2, H2. Okay, now compounds with metal. Metal means, okay, compounds with metal, like here NaH. Now hydrogen form compound with metal NaH, and it will form same with chlorine. Okay, now here compounds with non-metal. Non-metal means hydrogen form compound with the carbon, which is non-metal, CH4 CCl4. So it is same, H2 Cl2 NaH NaCl CH4 CCl4. Okay, so it shows the similarity with halogens. Now hydrogen shows similarity with alkali metals also, which are placed in group 1. So compounds of hydrogen are here HCl, H2O, H2S. Okay, now with metal also it shows the similar property, NaCl, Na2O, here H2O, Na2O is there, H2S, it will form Na2S. Okay, so as it shows the similarity with halogen as well as alkali metals, this it could not be decided whether the correct position of hydrogen was in the group of alkali metals or halogens.